Hey, what's up guys? This video is for section 8.5, which is using the distributive property, but we are actually going to do the opposite of the distributive property, or you can say we are going to undo this property. Now, when we undo or do the opposite of the distributive property is actually called factoring a polynomial. So let's look at that definition first of all. Factoring a polynomial is to find the factors that will multiply to the polynomial. So when you guys have any polynomial, you need to find the factors that will multiply to get that polynomial. So here are two examples that you guys see on the bottom of the screen. Now, if you guys have a polynomial, so notice this here is a binomial. We have 27y squared plus 18y. We want to find two factors or two different polynomials that will multiply to this polynomial. And I give you guys the answers over here. So the factors of this polynomial are 9y, that's one factor, times 3y plus 2. So you guys can multiply those two polynomials. This is a monomial and this is a binomial, and you guys will get this back. So let's try it. I'm just going to show you guys that you guys do get the same polynomial. If you multiply 9 times 3, that's 27. Y times y, that's a y squared. 9 times 2 is 18, and we only have one y. There's no y over here, so we just have one y. So it's 18y. So when you distribute, if you guys distribute, you guys do get this polynomial. But that's not the idea of factoring a polynomial. Factoring a polynomial, you guys are not going to distribute. You're going to do the opposite. You're going to undo the distributive property. So we have, you can say, the answer of the distributive property of a polynomial, and then you guys need to find the factors. Here's another example, and this is a trinomial here. So what are the factors when you guys find the polynomials that will multiply to the trinomial? Well, we have a negative 2ab times a 2a plus 4b minus 1. So what does it mean? Once again, if you guys distribute this right here, if you multiply, you're going to get this trinomial back. All right, so that's the idea. Now, what do we need in order to factor polynomials? One thing that we need is the GCF, which means the greatest common factor. So you guys already know what is the greatest common factor, and this is going back to the old days in elementary. You need to find the biggest number that actually is a factor of the numbers in the polynomial. So I'll do an example right now of how to find the greatest common factor. But just to give you guys an idea, if you look at these two numbers, 27 and the 18, 27 and 18, the greatest common factor is 9 right here. That 9 goes to the 27 and it goes into the 18. You guys can say 3 is also a common factor, but it's not the greatest one. 3 goes into 27, 3 goes into 18, but it's not the greatest one. 9 is bigger than 3, all right? Now, also, when you guys factor, the greatest common factor is going to be outside of the parentheses. And this is when you guys have a binomial or a trinomial. We are also going to factor a quadrinomial, 4 terms, but those steps are a little bit different than the ones I'm going to show you guys with binomial and trinomial. So first, in this video, I'll probably have to do 2 different videos. In this first video, I'll show you guys binomials and trinomials. In the next video, I'll show you guys quadrinomials. So let's check out some examples. So we want to factor. Notice the instruction says, number 1, factor the polynomials. So it doesn't say solve, doesn't say multiply. You want to factor. So you want to find what multiplies, what polynomials will multiply to the binomials that you guys see on the screen. So let's look at the first one here, 15y plus 10. So we want to know what multiplies to that binomial. First, we need to find the greatest common factor, GCF. So I'm going to look at the two numbers, and this is how you find the greatest common factor. There's a couple of ways you guys can do this, but I'll show you guys one that I like to use. I look at the number 15, and I'm going to write down the factors of 15, the numbers that go into 15. I know that 1 goes into 15, 3 goes into 15, 5 goes into 15, and 15 goes into 15. So those are the numbers that actually goes into 15. You always have the same number that goes by itself. Some people forget about this number here, but it's also a factor. 15 goes into 15 one time. Now I'm going to look at the number 10. So the number 10, the factors are the 1, the 2, the 5, and the 10. Well, guys, now you can look at the common factor, and this is going to be the greatest one, because for these two numbers, there's only one common number, one common factor. So these numbers here are common. They have the same factors. I know this one here are also common, but remember that we're looking for the biggest one. So 5 is bigger than 1. So these are common factors, but this is the greatest common factor. So I'm going to put a rectangle right here, and you guys will use that number. How do you set up your answer? Well, you guys will start with the parentheses, like this right here. You just put a parenthesis because you're going to have something outside, you're going to have something inside. Remember that that's a distributive property. You multiply what's outside to what's inside. But the one that goes outside is going to be your GCF. Right, so I'm going to put the number 5 outside the parentheses because that's my greatest common factor. Something else you guys also have to know. If they also have a variable in common, notice here that you guys have a y, and here you guys don't have a y. So if they do have both terms the same variable, that means they have a y in common. But right now, they don't have a y in common because this one doesn't have a y. What does it mean? You're not going to factor a y out. So I'm going to put the y inside the parentheses because I'm not going to take it out. That's factoring. If you guys are able to factor out the y, you have to. But right now we can't. So I'm going to start dividing this polynomial by the greatest common factor. So I'm going to take the number 15 divided by 5, and that's going to be 3. So I'm going to put 3 right here. I'm going to bring down the y here, and then I'm going to divide the 10 by the 5, and that's going to be 2 plus 2. And this is my answer. Why is it my answer? Well, if you guys do the opposite, remember, if you distribute, if you multiply 5 times 3y, that's going to be 15y, and 5 times 2, that's going to be 10. And that's what we want. We want to know what multiplies to this binomial. Let's do another one. Now the next one actually has some variables in common. If you guys look at this one here, 30x squared plus 50x to the third power. Well, both terms, they do have an x in common. Yes, I know they have different exponents, but when we say common variables, it's just the letter, the variable. So this term has an x, this one has an x. I'll tell you guys what to do with the x one right now, but they do have an x in common. What that means is you're going to factor, which means you're going to take out of the parentheses an x, because that's what they have in common. We also need to find the greatest common factor for the 30 and the 50. So first, let's do the numbers. I'm going to have the 30, and I'm going to write down the factors of 30. I know 1 goes into 30, 2, the 3, the 5, the 6, the 10 goes into 30, 15 goes into 30, and 30 goes into 30. Now I'm going to look at the number 50. So 50, I have the 1, the 2, the 5, the 10, the 25, and the 50. Okay. So you guys have the factors of 50. Now, look at these factors. 1 is a common factor, 2 is a common factor, 5 is a common factor, 10 is a common factor, and we don't have anything else. So the biggest common factor is the 10. So that means you're going to take out a 10. If you guys do not take out the greatest common factor, your answer is going to be wrong. If you guys use a different number, a lower number, for example, you think that, 5 is the greatest common factor, but you didn't check and you didn't find the 10 to be a common factor, you're going to be wrong. Because if you use 5, that is not the greatest common factor. So make sure you guys always check, always look for the greatest common factor. Now, remember that the variable I told you guys to factor out. Remember that both of the binomials, let me just highlight the variables, they do have an x in common. So what that means is, first of all, I'm going to factor out an x. I take out an x from the binomial. When you guys factor an x, you always keep the lowest exponent of the variables outside of the parentheses. So between the x squared and the cube, those are the exponents. Well, 2 is your lowest exponent. So I'm going to put a 2 outside of the parentheses. And now I'm going to put the greatest common factor of the coefficients, the numbers, which is the number 10 right here. So that's my greatest common factor. Let me just put here GCF so you guys know it is the greatest common factor. Now I'm going to start dividing. 30 divided by 10, that's going to be 3. Now here, guys, it's a little bit tricky. Notice that we have an x squared here. But remember that we took out the x squared. So if you guys had an x squared, but you took out the x squared, that means you don't have an x anymore here. You took out the x squared. And if you think about it, x squared is x times x, which means 2x. And let me just show you guys that here. X times x. So if you take out 2x's, so from here, you take out the 2x's, well, you don't have x anymore. So you just go to the next term. And the next term is 50 divided by 10, and that's going to be 5 plus 5. Now here, guys, you have x cubed. And you guys know that x cubed is x times x times x. So that means you have 3x's multiplying. But remember that we took out x squared, which is 2x's, x times x. So think about it. If you guys have 3x's here, but you take out 2x's, from those 3, you took out 2, you only have 1 left. So you are going to put 1x inside the parentheses because you only have 1 left. Now, if you guys multiply, if you guys distribute, remember we are undoing the distributive property, but if you actually distribute, well, if you multiply 10x squared times 3, that's going to be 30x squared. 10x squared times 5x, 10 times 5 is 50. X squared times x is x cubed. So we get the same polynomial back. And that's the thing, guys. If you guys multiply and you do not get the same polynomial, if a sign is different or a number is different, the answer is wrong. So my answer, my factors are 10x squared times 3 plus 5x. All right, let's try this one here. Now this one, notice, first you have to analyze, you have to understand the problem. And I do know that 12 and 6, they do have a common factor. But look at the variables, a c squared and a d squared. Here, we do not have a common variable. So that means that you guys are not going to take out a variable. You're just going to leave the same variables inside the parentheses. So first, let me put the parentheses so we know that we are going to multiply something. I'm going to look for the common factors of 12. 12, I know that's the 1, the 2, the 3, the 4, the 6, and the 12. For the number 6, I have the 1, the 2, and the 3, and the 6. Oh, so look, guys, the greatest common factor is not 1, 2, 3, it's actually 6. So I'm going to factor out a 6 right here. Now you guys are going to start dividing. So 12 divided by 6, that's going to be 2. And you guys keep the c with the square because we didn't factor out any c, we didn't factor out any d's. They don't have anything in common. For the variables, they're different. C and a d are different letters. Now the next one, guys, it's a negative 6 minus 6. That's negative 6. Negative 6 divided by 6, it's a positive. Well, that's going to be minus 1. Negative 6 divided by 6 is minus 1. But you guys have a d squared because we didn't factor out a d. Notice there's no d outside, so you're not going to take out a d from the d squared. Now you might be thinking, do we need that 1 next to the d? No, guys, you guys can erase it if you want to. You guys can leave it, but it's more common not to have the 1 next to the d. So my answer is actually all of this right here. 6 times 2c squared minus d squared. Now my GCF, greatest common factor, is the one outside the parentheses, which is 6, and you guys multiply those two. Okay, so let's go ahead and look at some more here. And this is just to give you guys more practice with different variables and binomials. Notice they're all binomials. In a second, my next slide is going to have trinomials, 3 terms. But right now we have 2 terms, binomials. So let's go ahead and look at the first one. Notice it says factor. So that means you guys want to find the 2 polynomials that will multiply to this binomial. What multiplies to 5x to the 5th power minus 20x squared y squared. So first, I'm going to put my parentheses. That's how we start. We have a parenthesis here. I need something outside. I need something inside. So now I'm going to look for the greatest common factor. Now guys, remember that list I showed you guys on the previous slide? You don't have to do that every time. If you guys can find the greatest common factor mentally, that's okay. You guys just look for the greatest one. Just make sure that it is the greatest common factor. So first, let's look at the variables. I noticed that the two terms, notice this one has an x fifth and this one has an x squared. So they do have an x in common. This one doesn't have a y, this one has a y squared. So this one, since it doesn't have a y, they do not have a y in common, but they do have an x in common. So I'm just going to highlight the x's so you guys know that that's what they have in common. So I'm going to put an x outside of the parentheses. The lowest exponents of the x's is the squared. So I'm going to put the squared outside of the parentheses. You always put the lowest exponent outside. Now you guys look at the greatest common factor of the coefficients, 5 and 20. And the greatest common factor is 5. 5 goes into 5. Yep. 5 goes into 20. Yep. So now you guys are going to start dividing. 5 divided by 5, well, that's going to be 1. So I'm going to put a 1 here. You guys have x to the 5th power. Remember, x to the 5th power is actually x times x times x 5 times x times x times x times x times x. So you guys are going to factor out 2 x's. So let me just give you guys a visual here. X to the 5th power is x, 2, 3, 4, 5. And you guys take out 2 x's. So I'm just going to cross out 2 right here. Okay. So how many do we have left? Hey, we have 3. So we have x to the 3rd power. Now you guys move on to the next one. And the next one is minus 20. So you guys divide negative 20 by 5, and that's going to be negative 4. We do have an x squared here, but you guys took out an x squared. So let me just show you guys here. X squared is x times x, but you guys took out both x's. So we don't have an x anymore, but we do have a y squared. And I'm bringing that down because we didn't factor out any y's. So this one stays the same. Same variable, same exponent. Once again, guys, you don't need that 1 next to the x cube, but my answer is right here. So you guys remember to find the greatest common factor, and that's the one that goes outside of the parentheses. And this is factoring. Every time you guys hear your teacher say factor the polynomials, you need to find what multiplies to the given polynomial. Okay, let's do some more examples here. Now this one's it's a little bit different because we do have a negative in front of the polynomial. So let me just circle that here. Every time you guys have a negative in front of the polynomial, you guys have to factor out the negative. That negative has to go outside of the parentheses. So let me just put the parentheses right here. And the first thing I'm going to do, I'm going to factor out the negative. Notice I left a little space here because I'm going to have some numbers and maybe some variables in between. But first, we need that negative outside of the parentheses. Let's look at the variables. I noticed that both terms, they have a CD and a CD. So that means that you guys can factor out a C and a D. Now look at the variables. Which ones are the lowest exponents? Let me just show you guys the C's. For the C's, the lowest exponent is actually 1 right here. Okay, so you guys will have a 1. I'm not going to write down the 1, but we have a C to the 1st power. And if you guys look at the D's, this one has a cube, this one has an exponent of 1. So my lowest exponent is 1, so I put the 1 here. I don't need it, but you guys just have an imaginary, invisible 1 exponent. Now, for the numbers, 21 and 3. 21 and 3. The lowest, sorry, not the lowest, the greatest common factor is 3. 3 goes into 21, 3 goes into 3. So now, you guys are going to start dividing. But here's the thing, guys. Remember that we do have a negative here, and we have a negative outside. Be careful when you guys divide negative numbers. Negative 21 divided by negative 3, that's positive 7. You guys have a C squared, but you guys took out 1C. So that means you guys only have 1C left inside. you have a d to the third power, but we took out a 1d here, d to the first power. So you only have a d squared inside, because from 3 you took out 1, so that's a squared. And now you guys divide positive 3, positive, that's a plus, divided by negative. Well, that's going to be negative 1 here. And there's a c, but you took out the c. We're not going to have a c. There's a d. You took out the d. We're not going to have a d. And guess what, guys? We do need that 1 here because we don't have any variables next to it. So your answer is right here. You guys have a negative 3cd times the quantity of 7cd squared minus 1. Make sure you guys have that 1 at the end. All right, so let's try this one again with negative in front of the polynomial. So first, this negative right here needs to come out. So I'm going to have my parentheses right here, and there's the negative here. I noticed that they do have an x in common. This one has a bx, this one has an x. So x can come out. I'm going to put an x right here, and the lowest exponent for the x's is a square. Now, when you guys look at the coefficients, the 36 and the 48, some people, and this is very common, some people say the greatest common factor is 6. Well, guys, no, it's not. There's a bigger one, and I'll tell you guys the greatest common factor, 12. 12 goes into 36, and 12 goes into 48. So that means that you guys are going to take out a 12. That is the greatest common factor. If you guys use 6 instead of 12, your answer is wrong. So make sure you guys use always the greatest common factor. So I'm going to start dividing. I have negative 36 divided by negative 12. That's going to be positive 3. I'm going to bring down the v because I didn't take out the v. So I'll just keep the v there. I have an x cubed, but I took out an x squared. So that means we have an x left right here. And then we have a negative 48 divided by negative 12. That's going to be positive. Negative divided by negative is positive 4. And you guys had an x squared. You took out the x squared. So we don't have x's anymore here. So my answer is right there. We have negative 12x squared times the quantity of 3bx plus 4. All right, guys, now it's time to look at trinomials. I have a couple of trinomials here. And the concept is the same thing. You guys just need to do it 3 times. You need to look for the greatest common factor for 3 different numbers. So we want to factor the trinomials. First, let's go ahead and look at the trinomial here. We have a 12jk squared plus 6j squared k plus 2j squared k squared. So all of this right here, guys, it is a trinomial. So first, I'm going to put my parentheses right here. I'm going to have a big parentheses because I'm going to have something inside, like a trinomial inside of the parentheses. I'm going to look for the common variable. That's what we want first. So I notice that this one has a j and a k, j and a k, j and a k. All right. So that means that we can factor out a j and a k. But now we need to know what exponent we need. So let's look at the j's first. I need to know what exponent the j has to have. So this one has a j to the first power, j squared, 2, and j squared. So the lowest exponent is 1. Let me just put a 1 right there so you guys know that that's the lowest exponent. So j to the first power is going to be outside. Do we need this 1? No, I'm just going to erase it. We don't need it, but it is going to be a j. Now let's look at the k's. This one has a k squared. This one has a k to the first power. Let me just put the 1 again here so you guys know exponent of 1. And this one has a k squared. So the lowest one is 1. The exponent, the lowest, smallest exponent is 1. So you put a 1 here. We don't need it. So I'm just going to leave it as k. Now, for the numbers. Now we do have 3 different numbers. So I'm going to start with the 12. Okay. I'm going to do the list here to show you guys how to find the greatest common factor for 3 numbers. But it's the same idea. So for the 12, you guys need to find the factors, the 1, the 2, the 3, the 4, the 6, and the 12. For the 6, which is this number here, is the 1, the 2, the 3, and the 6. And for the 2, right here, 1 and 2. Those are the only factors for number 2. So notice, the only common factor, or the greatest common factor, is 2. 2, 2, and 2. These ones, yeah, they have more common factors, but we are working with 3 different ones, the 12, the 6, and the 2. So the one that goes into those 3 numbers is the 2. So I'm going to use this number here outside of the parentheses, 2jk. Now let's go ahead and start dividing. 12 divided by 2, that's going to be 6. You guys took out the j to the first. There's a j, so I don't have a j here. K squared, you took out a k, so I'm going to have a k right here. Then I go plus 6 divided by 2. That's going to be plus 3. You guys have a j squared, but you took out a j, so you just have a j here. You guys have a k to the first, but we took out the k, so no more k's. You took out the k, you factor out. And now you guys look at the next one, positive 2 divided by positive 2. That's going to be positive 1. The j squared, you took out a j, so that's going to be only 1 j inside. And for the k squared, you took out a k, so we only have 1 k inside. We don't need that 1 next to the j and the k. You guys can erase it. Oh, I can't erase it anymore, guys. So I'm going to leave it there. But my answer is right here. You guys have the 2 factors that multiply to the trinomial. And you guys can check. If you multiply 2jk times 6k, that's going to be 12jk squared. 2jk times 3j, that's going to be positive 6j squared k. And 2jk times 1jk, that's 2j squared k squared. All right, let's try the next one. This is going to be the last one for this video, guys. I'm going to do a second part for this lesson, and it's going to be about factoring by grouping. That's when you guys factor quadrinomial 4 terms. But let's go ahead and try this one. So this one here, first of all, we do have a negative. So this negative is going to go outside of the parentheses. So I'm going to put here, and I'm going to put the negative outside. I'm going to look at the variables, RT, RT, RT. So I'm going to factor out an R and a T. Now for the R's, the lowest exponent, there's a 3, there's a 2, there's a 2, okay? Lowest exponent is 2. For the T's, there's a t squared, and t to the first power. So that means I'm going to have a t to the first power here. All right, so we got the variables. Now, the coefficients, 18, 12, and 6. Don't worry about the signs right now. Let's just focus on the greatest common factor. So I'm looking for the greatest. I'm not going to do the list here, but you guys can do that and find the greatest common factor. But the greatest common factor for all of these numbers is 6. 6 goes into 18, the 12, and the 6. And that's the greatest one. Not 3, not 2. Those are common factors, but the greatest one is 6. So now I'm going to divide. Careful with the signs because you guys do have a negative and a negative here. Negative 18 divided by negative 6. That's going to be positive 3. You have r cubed. You took r squared. So that's just 1r. You guys have a t squared, but you took out a t. So that's going to be 1t inside. Positive 12 divided by negative 6. That's going to be negative 2. You guys have an r squared. You took out the r squares, so no r's. T squared, you took out a t. So it's only 1t right here. And you guys go to the next term, negative 6 divided by negative 6. That's going to be a positive 1. And you guys have r squared. You took out the r squared. The t, you took out the t. We don't have any variables here, so we need the 1. Yes, we need it because we don't have any variables. So actually, my parentheses is a little bit big. Let me just close it, get it together, more closer to the 1. There it goes. That looks nicer. So my answer is this one, negative 6 r squared t times the quantity of 3rt minus 2t plus 1. So this is factoring, guys. Yes, it takes time. Yes, it's a little bit long, but you guys need to factor because the next step you guys will learn is how to solve quadratic equations. And solving quadratic equations, you guys need to know how to factor. All right, guys. So this concludes my video. If you guys like my videos, make sure you guys click on the like button. You guys can subscribe and make sure you guys practice your math, and I'll see you guys later.